In this video, we're going to do some more examples solving non-homogeneous ODEs using the method of undetermined coefficients. So I want to begin with an example right away. So let's solve y double prime plus 3y prime plus 2y equals e to the negative t. So my first step is we need to solve the homogeneous equation. So let's write that down. Y double prime plus 3y prime plus 2y would be equal to 0. That's our homogeneous differential equation. And now let's write the auxiliary equation. That would be r squared plus 3r plus 2 equals 0. And we could factor this. So this becomes r plus 2 times r plus 1 equals 0. And then we could write down what r is. And r is going to be equal to negative 2 or negative 1. All right, so we got the roots of the characteristic equation, or of the auxiliary equation. So now we can write down what the general homogeneous solution is. So y sub h will be equal to c1 e to the negative 2t plus c2 times e to the negative 1t. So in this case, just negative t. Next, let's try to find a particular solution. That is going to be the next step. So step 2 is finding the particular solution to the non-homogeneous equation. So the right-hand side, the function g of t in this problem is e to the negative t. So we want to use that to formulate our guess. So this is exponential. So this makes us think that we should let yp also be exponential and of the same form, so e to the negative t, but it needs to have a coefficient in front, so a e to the negative t. So let's try that out. Let's take some derivatives of this. So the first derivative of this would be negative a e to the negative t, and the second derivative of this would be a e to the negative t. So we have those two derivatives. And now let's plug these in. So now let's plug into, if we plug yp into the differential equation, we get yp double prime plus 3yp prime plus 2 times yp, and that needs to be equal to e to the negative t. All right, so our second derivative was a times e to the negative t, and then we have plus 3 times the first derivative, which was, I think I need a little bit more room, negative a e to the negative t. And then we have plus 2 times the guess, the original function, a e to the negative t. So that's what we have on the left. And on the right-hand side, this equals e to the negative t. All right. If we simplify the left-hand side, it's actually going to become 0. So we have 0 equals e to the negative t. But that's impossible. So this is bad. Something happened. This is bad. So the reason why we ran into this issue is because the guess that we made, so the guess is a multiple of e to the negative t. That guess showed up in the homogeneous solution right here. So if we take your guess, and it's the same as one of the homogeneous solutions, because it's showing up right there, and you plug it into the differential equation, it's always going to make the left-hand side be 0, because this right here is a solution to the homogeneous equation. So that's why this wasn't working. So let's just write that down. The reason this didn't work is because e to the negative t, our guess was a multiple of that. E to the negative t is a solution to the homogeneous equation. So if I be a little bit precise about this, or sorry, if I try to describe this in another way, I might say that there's an overlap in YH, so the homogeneous solution, this is the homogeneous solution, and YP, what we formed our guess as. Okay. As a result, we need to adjust our guess. So we need to adjust the guess. So here's how we're going to do that. We're going to adjust the guess by doing something really similar when we had a repeated root in the homogeneous case. We're going to multiply by t. So I'm going to call this thing the t fix. We're going to fix it by using t. That's what I mean by t fix. What we will do is multiply by t, multiply our guess by t, until there is no overlap in yp and yh. And for a second order ODE like this, we'll have to do that at most twice. So sometimes we won't need to do that at all. There's no overlap. And that's what we were seeing in the last video. We didn't run into a problem like this. But here we are encountering this overlap. So we need to do this t fix. So let's do that. So our previous guess was a times e to the negative t. So let's do this t fix. Let's do this t fix. In fact, maybe let's highlight this in a different color. T fix. Maybe let's also highlight this. Ooh, that's nice. Turning green. Okay, so t fix. Let's multiply it by t. So we get our new guess, y sub p, would be a times t e to the negative t. So that's our new guess. And then I need to take its derivative and its second derivative. The first derivative of this, if we do the product rule, ends up being a e to the negative t minus a t e to the negative t. And the second derivative of this, if I do the derivative one more time, I'm also just going to write down what it is. It's negative 2a e to the negative t plus at e to the negative t. All right. So now let's take those values and let's plug them in to our differential equation, the non-homogeneous one. So let's plug them into here. Okay, so doing this. So let's first write down what the second derivative is. The second derivative is negative 2a e to the negative t plus at e to the negative t. That's the second derivative. So that's going to get added to 3 times the first derivative, which was a e to the negative t minus at e to the negative t. And that's going to get added to 2 times yp, which was at e to the negative t. So this whole thing needs to be equal to e to the negative t. All right, so what we want to do now is let's simplify this left-hand side. So if we look at the left-hand side, there are 2 types of terms. There are terms that just have e to the negative t and a coefficient in front like this, but no t. And there are terms, let's put this in a different color. There are terms that have e to the negative t and also a t with it. So if we focus first on the terms that don't have that extra t, multiplying e to the negative t, let's underline all of those. So here was one. In the next parentheses, we'll get one from multiplying the 3 times this term. In the next parentheses, we don't have that because we have t multiplying e to the negative t. So if you combine these 2 terms that I've underlined in blue, we would get just a e to the negative t, because we'd get like 3a e to the negative t minus 2a e to the negative t, and that just becomes a e to the negative t. So now all the terms that have that extra t in them, so here's one. I also get one from distributing this 3 to this term, so that'll give me a minus 3 as a coefficient. And there's also one here that has a 2 as a coefficient, technically a 2a as the coefficient. But all of those perfectly cancel. So I just get plus 0 there. So this equals e to the negative t on the other side. So a e to the negative t should be equal to e to the negative t. So at this point, I can match up my coefficient and say that a just has to equal 1. So we're ready to write down a particular solution. So our particular solution, y sub p, would be equal to 1 is the coefficient, t e to the negative t. Right, so we had multiplied it by t to adjust our guess. All right, so we are now ready to write down the general solution. So the general solution, y, is equal to the particular solution to the non-homogeneous plus yh, this general solution to the homogeneous equation. So we get y equals, and yp was t times e to the negative t, And the solution to the homogeneous equation, recall that that was c1 times e to the negative 2t plus c2 times e to the negative t. So that is our general solution. All right. So what I want to do now is I want to do sort of a series of examples, but just focusing on what will our guess look like? Because that's often the most challenging part of these undetermined coefficient problems, figuring out what our guess should look like. Because after we got our guess, it's mostly just computation. All right, so I want to guess the form of the particular solution. So I just am worrying about the particular solution to the following non-homogeneous ODEs. So in part A, we have y double prime plus 3y prime plus 2y, so the same thing that we had before on the left-hand side, being equal to a different function on the right-hand side. This time we have cosine of 3t on the right-hand side. So because the left-hand side is exactly the same as before, we know the homogeneous solution. It's c1 times e to the negative 2t plus c2 times e to the negative t. It's the same homogeneous solution we had above here. So now let's guess our particular solution. So we form the particular solution guess by looking at what g of t is, so this function on the right. So by looking at the fact that that's a trig function, cosine of 3t, we've seen from our table on formulating a guess that we need a cosine term with the same term in the middle, inside the parentheses. It's got to be 3t, and I need a coefficient in front. But I also need a sine term. I will also need a sine of 3 term, and I'll put a coefficient in front of that, so b. So sort of conceptually, the reason why I can't just have cosine is because when we start taking the derivative of it, we get sine terms. So we're going to need a way to sort of cancel out those sine terms, and the way to cancel out those sine terms is to put a sine term in my guess, and now to play around with the coefficients to make it so that it'll work out to cosine of 3t exactly. All right. So notice here that when we look at the homogeneous general solution, that this doesn't match. It doesn't match yp at all. It doesn't match what our guess is at all. And what I mean by that, just being a little bit more precise, is none of the functions in this homogeneous general solution, either e to the negative t or e to the negative 2t, are scalar multiples of the functions that appear in my guess. It's cosine of 3t and sine of 3t. So in other words, there is no overlap. There's that keyword we were using before. So there's no overlap. We're really happy because we don't have to do that t fix. All right, so let's do another example. In this next example, we have the same thing on the left-hand side. And whoops, I need to put a derivative here, a prime on that y. All right, but the function on the right-hand side is different. Now we have t times e to the negative t on the right-hand side. All right, so we know our homogeneous solution. It's the same thing as before. But the function on the right-hand side, g of t, is now different. It's t times e to the negative t. So let's first guess what our particular solution is, and then we'll see if we need to adjust that guess at all. So g of t is now a little bit more complicated because it's a product of two different types of functions. We have a linear function, that's this t, and we have this exponential function, e to the negative t. So our guess needs to be a product of a linear function and an exponential function as well. So yp is going to be, I'll first put something kind of arbitrary linear. So that would be something like a t plus b. And then something exponential of the same form. So e to the negative t. So we have this linear piece and we have this exponential piece. That's how we'll sort of handle scenarios like this, where the function on the right-hand side is a product of two types of functions that we know how to handle. In this case, a linear one and an exponential one. All right, so now let's see if yp and yh have any overlap. So to check that, let's just go ahead and distribute in e to the negative t. If we do that, we get a t e to the negative t plus b times e to the negative t. So now if we compare this guess that we have with the homogeneous general solution, let's look to see if there's overlap. And here there's definitely overlap. There's a lot of overlap. So e to the negative t, I see that here as well in the homogeneous. And I also see the t e to the negative t in the homogeneous general solution. So this overlaps with the YH. So the reason why that's happening on a more conceptual level is when we talked about our homogeneous solution, the root of this is r equals -1. And notice that that sort of matches up with what coefficient I see in the exponent on the right-hand side here. I see a -1 in front of the t. So that the fact that that matches up is carrying through all the way in my homogeneous solution. I see an e to the negative t in the homogeneous solution. And because it's a repeated root, I get t e to the negative t. So I didn't see another e to the t there. And that's and the fact that we had e to the negative t on the right-hand side of the differential equation is what made it appear here in the guess as well. So that's what's causing the overlap. What caused the overlap again is the fact that the root of the characteristic equation was matching up with sort of the form that I saw on the right-hand side here. So we need to do a t-fix. So let's write down a better guess. That first guess didn't work. So we need a better guess. In fact, this guess didn't work, so let's put a sad face here. So better guess, let's multiply by t. So my new guess, yp, is going to be t times at plus b times e to the negative t. All right, so if we have this, now let's check this again. Let's distribute. If we distribute this, we'll get at squared e to the negative t plus bt times e to the negative t. So comparing that with the homogeneous general solution, there's still an overlap in this term. This function, ignoring the constant, the t e to the negative t, we see that in the homogeneous general solution as well, in the c2t times e to the negative t term. So this also overlaps. This also overlaps with YH. Okay, so that makes us sad. And the reason why that was happening, why it's still overlapping, is because this was repeated. Our root was repeated. It had multiplicity 2, and that's why, on a more conceptual level, we are running into this problem twice. So multiplying by t once wasn't good enough. We actually need to do it again. And if we do it this one more time, we will get the right guess. So this will be the best guess. So let's multiply by t one more time. We'll now get t squared times at plus b times e to the negative t. And if we distribute this out, we will get at cubed e to the negative t plus bt squared e to the negative t. So let's zoom it out a little bit. And now let's compare this to the homogeneous general solution. So if we look at these functions, so I see t squared e to the negative t, well, that doesn't show up as a function in the homogeneous general solution. Same thing with t cubed e to the negative t. That doesn't show up as one of the functions in the homogeneous general solution. So we've now multiplied by t enough so that none of these functions in my particular solution appears in the homogeneous solution. And that is what we need. So at this point, there is no overlap with YH. And that makes us happy. So happy face. That's how we know that our guess, this guess right here, is going to work. So this was our best guess. All right, so let's do one more example. Let's even make the right-hand side even more complicated. So, oh, and I'm changing up the left-hand side a little bit as well. Okay, so we have this differential equation. So the right-hand side now has a polynomial term, it's got an exponential term, and it's got a sine term. So to save time, I've gone ahead and written down what the roots of the characteristic equation are. But you should check this. Check that these are right. So we get that r equals 1 plus or minus I. And because of that, our homogeneous solution is going to be C1 times e to the, so technically the alpha here is 1, alpha is 1, and then there's technically a 1 as a coefficient of the I, that's our beta. So this term is e to the alpha t. This term is cosine of beta t. That's where we get those, that's why it's just e to the t and not like e to the 5t. So we have that, and then we also have plus c2 times e to the t times sine t. That's what our solution to the homogeneous equation looks like when we have complex roots like this. All right, so now let's formulate our guess. So the form of the right-hand side is we have 7t e to the t times sine t. So we know that there's a linear piece. We know that this is an exponential piece. And then we have a sine function, so we have a trig piece. Let's use that to form our guess. Okay, so when we form our guess, from the linear part, I know we're going to need something linear. So I'm actually going to call this a1t plus a0, and we'll see why in a little bit, but I'm going to call it that instead of just at plus b, so a1t plus a0. And then I need something for the exponential term, so I need something of the same type, so e to the t. And then I need this trig piece, so I need sine of t. But we might remember that when we had either sine or cosine on the right-hand side, in our guess, we needed both. We needed a sine term and we need a cosine term. That's still going to be true here. So I'm also going to need a cosine term. But this cosine term needs to be multiplied by everything that sine was. It will also need to be multiplied by an exponential, so e to the t, and it will also need to be multiplied by something linear, but it may not necessarily be the same linear thing. So I'm going to call this thing b1t plus b0. And that's why I chose this labeling for my variables. So notice that we have a linear piece here, we have an exponential piece, and then we have our trig piece, we have sine. So trig piece, we have sine. And in the other part as well, we have a linear piece, we have an exponential piece, and we have this trig piece, and the trig piece being cosine. So it's really important that I have something with a sine and something with a cosine when the right-hand side of our non-homogeneous equation is either sine or cosine, or if it's both. Okay, so the next thing I have to sort of check is this guess good, or do I need to do a t-fix? So to answer that, we need to ask ourselves, does our particular solution, any part of it, overlap with the homogeneous solution? So the homogeneous solution, in it, I see e to the t times sine of t as one of the functions. But I see that in the particular solution. If we were to distribute the a0 times this e to the t sine t, that would be overlap. So that's definitely overlap. That overlaps with the homogeneous solution. But there's a little bit more overlap. In the homogeneous solution, we also have e to the t times cosine of t. But I see that in my guess over here, if we were to distribute b0 into this, that's also contributing this overlap. So on a conceptual level, the reason why that's happening is because our root, 1 plus or minus times I, it appears in the form of what g of t is. So for example, alpha being 1 is exactly what the coefficient here is in g of t, in the coefficient of t in this exponential part. And beta being 1 is exactly what appears inside of this, inside of my sine. So the fact that that root is sort of appearing there, that's what makes us need to adjust our guess. That's why there's an overlap here. Okay, so we need to adjust our guess, and it'll turn out I'm only going to need to multiply by t once here. So let's do it, and then we'll talk briefly about why. So if we multiply by t, we'll get t times the first part, a1 t plus a0 times e to the t times sine of t, plus t times the second part, so plus t times b1t plus b naught times e to the t times cosine t. And now there's no overlap with this, because if I were to distribute this t in, I'm not going to have just e to the t sine t like I have in the homogeneous case, or e to the t times cosine t. It'll always be multiplied by this t at the least. I might even get a t squared term. So there's no overlap now. So this is the proper guess.